All right, now we're on to page 2 of the algebra review, and we're wanting to expand here. So back in algebra, you may have done a box or a cube or something, or you called it area model. I don't know. I don't prefer that. It's fine if you want to do that. My daughter, who is in college studying to be an actuary, something nerdy, she does that all the time. Hey, whatever works for you. But for me, I think the simplest thing to do is just take this first term, 5x, and we're going to multiply it by this thing here. So 5 times 2 gives me 10. X times x gives me x squared. And then I'm going to do that again. 5x times negative 3 gives me a negative 15x. Then I go to the next term, and I do the same thing. 2 times 2x is 4x. 2 times negative 3 is negative 6. There are my 4 terms, and anything that can be put together, I'm going to do that. So negative 15 plus 4 is negative 11. And then there's my answer. So it's a little quicker, a little more efficient. That's what you'll see professors do. But again, if the box helps you organize yourself, then by all means, don't worry about it. Here, same thing. I'm going to take this times this. This is odd looking, but we're going to follow normal exponent rules. So my base is the same. 3 times 3 is, or the 3's are the same. So I'm going to keep that base, and I'm going to add their exponents. So n plus 1 times n plus 1, or n plus 1 plus n plus 1 would be 2n plus 2. I'm going to add the exponents together. So it's no different than if you had x squared times x to the third. The x bases are the same, so you keep it x, and you'd go 2 plus 3 is 5. That's exactly what we did right here. 3's are the same, keep the base the same, add the exponents together. Okay. Now, as far as the outside goes, I've got 4 times this, which I'm just going to write like that. 4 times 3n plus 1. And then in this next part, I have a minus 4 times there. So I can kind of see that those are going to cancel. And then the last thing I have is negative 4 times 4, which is a negative 16. So in the end here, I have 2n plus 2 minus 16. And that's good enough for that. Okay. This one here, you got to be a little careful. Anytime we see squared, we have to remember that squared means that thing times itself. So don't just distribute that square. That's going to be the temptation, is that you'll just want to square this, and be done. But instead, you got to take your time. This is this times this, which will be 16x to the 14th. You would get that term. What you would miss is this middle stuff. 4x to the 7 times 3 is 12x to the 7th. Then another 12x to the 7th. Then 3 times 3 would be 9. So again, if you just distributed it, you'd have this and that, but you'd have this middle missing. And you don't want to miss that. Put those two in the middle together. There's 24x to the 7th plus 9, and there's our answer. As far as expanding these go, we're going to follow our exponent rules. So again, I have the same base, 3 and 3. So that's going to give me 3a plus 2a is 3a. All right, and then I've got x to the 5a, x to the 8. I'm going to add that together to give me 5a plus 8. I can't really do anything because of the a. Can't really smash it together any more than that. So I'm going to leave it like this. And then I've got this 3 to the 3a. That's going to stay 3 to the 3a. But then in this case here, I can subtract these exponents. So I'm going to have x to the 5a plus 8 minus 2, which is going to be 5a plus 6. So that's awfully weird feeling, I'm sure. You work with something like that often in algebra, but that is just following our rules and doing what what we know is right. In something like this negative 4 is a little awkward. What you can do is you can give that to, since all of these are multiplying together, you can give that negative 4 to everything and kind of work it through that way. So if we do that, we're going to get 4 to the negative 4th. You got to make sure the number gets a 2. We're going to multiply here. So negative 2 times negative 4 is positive 8. 6 times negative 4 is negative 24. 3 times negative 4 is negative 12. Okay, and then from here, let's kind of work out our negative exponents. So this 4 to the negative 4 means that we'll drop this down and we'll do 4 to the 4th, which is 256. Okay, we have the x to the 8th up on the top. This y to the negative 24, that's going to come down. Those 24y's will be down here. And this negative 12, that pushes this up. So these 12m's are up on top. Again, just a negative exponent just means that it should be on the other level. If it's on the top, it should be down. If it's down, it should be up. All right? So there's our simplified one there. And then on this one, we want to factor these out and then see if anything cancels. So when we factor, again, you can use your box and work it out that way if you want. But for me, I look first, I see the x squared is plain, so I'm looking for two numbers that multiply to equal 64 and add to equal 16. And that would be 8 and 8. All right, and then I'm looking for two numbers that multiply to equal negative 16 and add to equal 6, and that would be 8 and negative 2. Okay, x plus 8 and x plus 8 are the same factor. They will cancel each other out, and that's going to leave me with a factor of x plus 8 on the top and x minus 2 on the bottom. May be tempting to try to knock these x's out, but again, this x plus 8 is one factor. Anytime you put a plus or a minus, that puts it as one thing, and so you got to treat it together. The only thing that would cancel an x plus 8 would be another x plus 8. All right, if we were to expand x to the 5th minus 3 to the 8th power, which would be amazingly boring, but if we were to do it, what would the first term be? So if you can imagine writing this out 8 times, the first terms in all of those would be this x to the 5th. So what you'd have is you'd have x to the 5th and then another x to the 5th and another x to the 5th. You'd be multiplying all these x to the 5ths out 8 times, right? And so if I had 8x to the 5th, I would add these exponents, 5, 10, 15, and what I'd end up with is x to the 40th power. That would be my first term. Doesn't matter what anything else is. If you remember like Pascal's triangle and binomial theorem and all that stuff from pre-calc, we could apply that here for other terms, but our first term's pretty easy. It's just that one there. Okay. Again, factoring, we're looking for two numbers that multiply to equal this and add to equal that, and with just a little bit of thought and patience, anybody should be able to get x plus 8, x minus 3. All right. On this one's a little stranger. We don't see this happen very often in calculus, so don't get too panicked if this one kind of blew you away. What we have is an x minus 3 here and an x minus 3 here, so we can actually pull that x minus 3 out of both of these terms. That'd leave you with 4 and minus 25x squared. If you saw that, that's good. But we can go a little bit further here. 4 minus 25x squared is what we call a difference of squares. 4 is 2 times 2, and this is 5x times 5x. So anytime we have a difference of squares, we can always write it as 1 plus the other perfect square, and then 1 minus the other perfect square. And so if you were to expand this, 2 times 2 would get you the 4, this times this would give you that, and then the outside and the inside would cancel each other out because of that positive negative there. So this is the full factoring. Again, if you saw this first line, that's good. This is a little bit better. All right, and then in terms of solving these equations out, what we want to do here is factor this. So we're looking for two numbers that multiply to equal negative 20 and add to equal 1. Those are 5 and negative 4. And now we're going to go one step further and say, well, what could x equal to make this 0 or this 0? So if x was negative 5, then negative 5 plus 5 would be 0. That would 0 this all out. Or x could equal 4. And that would 0 that part out. Okay, one or the other. And then the same thing here. Now this one has x squared minus 25 less than 0. So if we factor this, this is x plus 5, x minus 5. All right. So now I got to think, well, what would make it less than 0? That would be, well, let's maybe first say, well, what would make it equal 0? And that would be 5 or negative 5. So now if I think about like a number line, negative 5 and 5, well, what if I put a number, say, less than negative 5, say negative 10? If I were to put negative 10 in here, that would give me a negative, and that would make this negative. And negative times negative would make a positive. So if I put any number less than negative 5 in, it'll always give me this negative-negative combo, which turns into a positive when I multiply. Now, if I were to put something between negative 5 and 5, and say if I put 0 in, 0 plus 5 would be 5, that would become positive now, and 0 minus 5 would still be negative. Positive times negative would give me a negative. Now, that would give me something less than 0, anything in here. And then if I were to put something bigger than 5, say I would put 20 in, that would make this positive, and now this would turn positive. I'd have positive times positive, which now isn't that, it's not less than 0. So I'm looking for the range that would give me less than 0, and that ends up being anything between -5 and 5. So in other words, what I did was I kind of figured out, well, when does this equal 0? And those are my kind of stop points here. And then I said, well, what happens in the intervals between and before and after them? All right, we'll work a lot more with this idea when we get into derivatives and stuff. But that's your worksheet for algebra review.